Namaste to everyone. I'm here to give a presentation on the analysis of the structural, electronic, and mechanical properties of hexagonal boron nitride graphene hybrids. These are the 2D layers, and the analysis is based on density functional approach. Presentation is comprised by following points. As you know, graphene was discovered in 2004. Even being a semiconductor, it shows a zero band gap, and it has a large surface area, excellent mechanical strength, high electrical conductivity, thermal properties, and a good absorption capacity. It has wide range of applications in solar fields, hydrogen storage materials, electroluminescent devices, electronic gas sensors, electrode materials, biohybrids, and in many two-dimensional devices. Boron nitride is another 2-dimensional material. It was discovered in 2005. It has all the similar kind of properties like as graphene, except the high large forbidden energy gap, means band gap. It is around 5.9 electron volt. So it means boron nitride is an insulator and graphene is a conductor. When both are sandwiched or like as a graphene 2D layer is sandwiched in between the boron nitride 2D layers, or boron molecules are replaced by carbon pairs or graphene layers, then we have a 2D hybrids. When these hybrids are made, then we have a band gap will be tuned, and the electronic properties will be enhanced, and its response will be higher than pristine two-dimensional materials. And in our study, structural electronic properties of different two-dimensional hybrids are analyzed. In this process, density function theory is approached by following a SISTA code, and when a SISTA code is followed, we have to prepare an input file in which we have to give few parameters belonging to a system. First of all, we should have XYZ coordinates, and then after the minimum energy required to keep for the analysis, or to keep in a cell, that is called the cutoff energy, and for further electronic properties in the density of state analysis and band analysis, key points will be required. K means 2 pi upon lambda propagation constant. Key points along X, Y, Z axis are required, as well as the box size must also be optimized. So these three parameters, first of all, are optimized. Optimized means when system got in an equilibrium position, at that time, what will be the values belonging to the energy, belonging to the key points, belonging to the size, and after optimized means getting these three values, the whole system is optimized. Optimized means that kept at an equilibrium position, and on the basis of the outputs, when system got an equilibrium position, the further analysis is processed, and when system got equilibrium position, the forces between the atoms must be near around 0.001 electron per angstrom. This values can be modified according to us. So these are the two-dimensional not sheets, layers. Sheets are constant. Layers, there is no constant in all the directions. So first of all, in our previous work, it belongs to a project sanctioned by T-Cube third, and this is the work belonging to the see, we can hear a two-dimensional atomic layer is here. 6 carbon pairs. 6 carbon pairs are replaced by 6 6 boron nitride molecules are replaced by 6 carbon pair atoms, and it represents one-dimensional atomic hybrid layer. So it shows a zero band gap. First, it comprised of around 16 boron BN molecules. By replacing a single molecule by carbon pairs one by one, so the band gap gradually reduces. First of all, it was an insulator, this system, and by gradually replacing the BN molecules, it gradually transformed into a conductor. And for this hybrid atomic sheet, we have a zero forbidden energy gap. So now in the current, it has also published in Physica E. Now further analysis, this atomic layer is transformed and to different these sheets, and the width is gradually increased. First, 2 atomic layers are taken, 3 atomic layers are taken, and 4 atomic layers are taken. And let's see which kind of effect will be observed when vacancies are produced. So in 3D, three atomic layer hybrid sheets, 1 vacancy and 2 vacancies are produced. Similarly, with fourth layer system, 1 and 2 vacancies are produced. And so totally 7 systems are analyzed in this work. To study the application part of these systems, electric field is applied perpendicular to the sheet, perpendicular if it represents to the length, the perpendicular sheet, and stress is applied along to the z-axis as well as along the y-axis. So the length represents to the is kept along the z-axis, and the width is along the y-axis. And the effect on the density of states is observed. In the coming slides, we can see. So these are the hybrid 2D atomic layers. Talking about the how density actually distributed between the atoms, we can see between the carbon atoms, a dumbbell shape, and the charge is distributed. So in other words, distortion can be seen like as a dumbbell shape, hence it represents the covalent bond between these atoms. Talking about the charge distribution between the boron and nitride, we can see the concentric circles around the nitrogen, but these are a little bit deformed. So concentric circle represents the ionic nature, and deformation little bit deformed toward the boron atom. Boron atom means there is a partially ionic, and ionic represents the concentric circles, and deformation represents the covalent band. So it represents a partially ionic and covalent bond between boron and nitrogen. These are the color codes. Pink color represents this one, the charge density, the concentration. Sorry, yes, charge density, Coulomb per Bohr cube. NR represents the charge density here. So in this analysis, in the density functional theory, the ground state electrons means pseudo potentials are taken in which the core shells are not considered for the further analysis. Only valence shell electrons are taken. So here, because of it represents the density of the valence shell electrons, in which the s orbital, p orbital, and d orbital will contribute. So this table represents to the variation in the bond lengths between the atoms when without vacancy and with vacancies. We can see without vacancy, the bond length between boron and nitrogen is around 1.5, but when vacancy is produced, it is increased by 0.01 further. Similarly, for CC, we can see it is further increased in the similar manner, and in other and in between the other atoms, similar kind of thing is observed. Talking about the 4-layer atomic hybrid layer, see we can the bond length between this atom 1.45, but again 0.01 is enhanced. So by producing the vacancies, the bond length is a little bit increased. So the strength is reduced little bit further. How density electrons are distributed, that represents to the projected density of states as well as the density of states. Here, this one represents the density of states. Projected density of states, in which the electronic distribution of the constituent atoms is analyzed. Since the hybrid is comprised of carbon, nitrogen, and boron atoms. So carbon and the valence shell 2s2p electrons are there. So we can see clearly 2 2s, the red mark is representing to the 2s, and 2p represents the green color. So it represents the valence band, it represents the conduction band, and the red mark dotted line 0 represents the Fermi energy level. So below the Fermi level, valence band is there, below the upper the conduction band, and we can see the green color curve is in the valence band. So 2p electrons are contributed highly in the valence band, and similarly in the conduction band. Comparing to all the constituent elements, we can see the higher contribution is observed by 2p electrons of nitrogen compared than remaining to boron and carbon. And in the conduction band, we can see carbon and boron is boron atomic electrons are contributing higher than nitrogen. And it represents to the total density of states. It represents for a whole system. These are belonging to the constituent elements, means atoms, but it represents the whole system to the hybrid layer. Sorry. So we can see there is a zero band gap, no forbidden energy gap, but it actually obtained because of the contribution by the orbital electrons of carbon atoms. So we can see carbon here the maximum actually the distribution around the Fermi level. The carbon atoms are similar as shown here, and we can see around a little bit gap is showing by other atoms, but due to this contribution by these atoms, we have zero gap. So no forbidden energy gap. So all the states belong to the nature of a conductor. So we can see when a single atomic layer is transformed into 2D layer, 3D layer with vacancies, and 4 layer, which kind of thing is observed. We can see no forbidden energy gap with 2 layers. By further increasing the length width, we can see the further enhancement in the density of states of the ground state electrons. With vacancy, the further shift with double vacancy, no, there is no touch to the x-axis, means ground state energy of electrons are enhanced actually because of the vacancy. Similar kind of things also observed with 4 layer hybrid layers. So by increasing the width, okay, so lower density electrons of lower electrons in the energy states are enhanced. It represents to the band diagrams in all the cases. 0 represents the Fermi level, upper level conduction, and lower the valence band. We can see there is no gap is associated with any one. So all represents to the conduction metallic nature. So when electric field is applied perpendicular to the sheet, okay, along to the length and perpendicular to sheet. So we can see electric field is increased from 0 to the 9 volt per angstrom. Then till to 4 volt per angstrom. There is no change in the distribution of the electrons, but afterwards the ground state energy of electrons. See, we can see the upward shift is observed, starting from the 5 volt per angstrom, and then after gradually little bit variation in the bottom levels in the density of states, but at higher is observed at 9 volt per angstrom. Means when density of states are enhanced means the lower energy is enhanced, so that electrons will respond faster to the applied field. So when these materials used in the sensing devices, then the response time will be higher at this at 9 volt per angstrom than than at lower voltages. Similar kind of thing is observed with 3 layer hybrid, and with single vacancy and double vacancy, we can see the shift in the density of states is higher beyond the 5 volt per angstrom. Okay. Similarly, with two vacancies, shifting is higher. So with vacancy and by increasing the applied field, so the response time will be higher. Same thing is also observed with the 4 layer hybrids. You can see here till to 4 there is no change, but then after shifting is observed. See, we can also see with 1 vacancy and double vacancy. Now stress when is applied, then it is observed that by increasing the length, it represents the positive axis represents the increasing the length, and negative represents the compression. During the expansion, we can see this black colored curve is shifting or little up than the other curves, means 2D layer hybrid has a higher strength during the expansion. And during the compression, we have the pink colored. This time we can see this system represents the pink colored curve. That is a 4-layer with along with the 2 vacancies has a high strength during the compression. And the stress is applied along the y-axis. Y-axis means along the width. When along the length, when the stress is applied, then during the expansion, there is all hybrids are representing the similar nature, while compression, this one green color means a 4-layer hybrid represents to or give is giving or showing higher strength. It represents to the breaking point. So by applying first of all, by applying the stress, the strength is observed, as well as the electronic nature can also be enhanced. That can be understood by following these figures. We can see the percentage change in the length is shown here. Delta L 0 means 0%, -1 during the compression. Minus notations represent to the compression, positive represent to the elongation. So 2%, 4% when length is reduced during the compression, we can observe the shifting till to 4%. There is no change. But then afterwards, shift in the bottom distribution electronic states are a little bit shifted upward. Similarly, here can also be seen after 6%, the shifting is higher. Means states are shifting toward the upward direction. With the 3-layer hybrid, the same thing is observed. The shifting in the bottom, we can see the shifting in the bottom layers. With 1 vacancy, the same kind of thing is observed. So see, during the elongation, the shifting in the density of states is observed. With the double vacancy, the same thing was observed. With 4-layer, you can see at higher the variation in the length, the shifting is observed. But at lower percentage change, there is no change in the distribution of the density of states. Similarly, at higher values during the elongation, same thing is observed. So by applying the strain as well as the electric field, the density of states are shifted based on the how much electric field is applying and how much strain is produced. So a single atomic layer is transformed into 2D layers, 3D and 4 layers, and produced single and double vacancies. So it is observed without vacancy, it shows the higher strength. Partially ionic and covalent bond is observed between carbon and nitrogen, and zero forbidden energy gap is obtained because of the contribution made by the carbon atom electrons. All hybrids exhibits a metallic nature, and during the increase in the width, it is also observed that the shifting in the density of shades, bottom density of shades is observed, and band diagrams exhibit the metallic nature. And by applying the electric field, it is observed that at 9 volt per angstrom, the higher shifting in the bottom of the density of shades is observed. And similarly, by applying the strain, we got that 2D layer and 4D layers are showing the higher strength along the y-axis, and 4-layer along with 2 vacancies shows a higher strength along the z-axis. And so by this kind of functionalization means by the presence of the external source, density sources are shifting. Shifting means if these devices, if these hybrids can be used or kept in the devices where the conduction is on, when the shifting was minimum, then if there is no conduction, but by applying the electric field and strain, the systems which were not conducted, they start to conduct. So means the response time will be higher, and the electronic properties will be enhanced by the application of electric field and strain. So this can be, so because of that, this kind of outcomes, these devices or hybrids can be utilized in device applications also. And this work was sponsored and funded by TQ Third, and helpful discussions. These experts contributed a lot, and two project assistants also worked on. They came from Himachal and stayed here 1.5 year. Thank you all.